Well, it's time for us to get into the next session, machine learning for cognitive computing. This session is going to be very interesting and we will understand more details of machine learning which is going to be used in the cognitive computing. We all know one point that continuous learning without reprogramming is the heart of all cognitive computing solutions. Means that we need to make the cognitive systems in such a way that they continuously learn. They should evolve, but you should not go ahead and reprogram it. It will defeat the entire purpose. Many of the cognitive systems that we are building today has the capacity to acquire, manage, and learn from the data. And all of them, if you look into it, will have machine learning as the core for the systems. And machine learning is a discipline which is not only just from computer science, it also has got statistics and psychology as part of it. Finding patterns in the data. Now, what will a basic machine learning algorithm look for? Simple patterns. The patterns in the data, and based on the patterns, the action or recommendation can be taken. What can be the pattern? The pattern can be simple, similar structure or similar values or proximity. A pattern can be even proximity here, as you can understand that how close one item is to another can be a deciding factor. Now, let's go into proximity a little detail. It is an important concept and we should understand that. Two data strings representing things or concepts in real world are certainly close when their abstract binary representations have similar characteristics. This is proximity. Two data strings representing things or concepts in real world are definitely close. That's called proximity. So this idea of even looking into the proximity is very important for us to even find the patterns. So the patterns need not be simply the structure or need not be simply the values. It can even be the proximity. We need to understand this aspect. The cognitive computing systems definitely uses machine learning algorithms the most, and they are based on inferential statistics which can help in determining or discovering the patterns that guide the behavior. Please understand the term inferential statistics which is being brought in for the first time in this session. We are talking about the cognitive systems. We are saying that the cognitive systems is using machine learning algorithms, but we are now newly saying that it is based on inferential statistics which will help in detecting or discovering patterns to guide the behavior. Now coming to the next point, what is inferential statistics? Inferential statistics is like making an educated guess. We are going to make guesses. For an instance, we can make guesses about a big group of things, a population maybe, based on what we know about a smaller group from that big group, a sample we are taking. Based on the sample, we will understand and we will guess what could be the bigger population be. I want to know the average height of all the students in a particular school. But measuring each one's height in the school could be very difficult and it could be complicated. So what do? We pick up sample. We pick up few students and we measure the height. And from that, we can make guess about the average height of all the students. The sample helps you in guessing the height of all the students in the school. So this is a sample which is helping you to get the prediction about the population. This is called inferential statistics. This is a very important term that you need to understand. Now, how do we choose an ML algorithm? There are multiple algorithms available. Many of them are claimed to be the best. And how do we choose? When you choose an ML algorithm, you need to think about certain points. The first one, is there an existing source of data and associations between data elements to solve the problem? This is a very important aspect. Do we have existing source of data and associations between the data elements to solve the problem? This is first one. Do I know what kind of patterns my data has? My data is there. It is a strong, voluminous data. Do we have any idea about the patterns? Can I give examples of how I would identify and exploit these patterns manually? So it's all about understanding the pattern. It's all about extracting the pattern, and we need to think in that perspective to choose the right ML algorithm. Let's get a little deeper into machine learning. Machine learning algorithms are majorly classified into three types: supervised, unsupervised, reinforced algorithm. But the fourth one is also there, which is evolving very strongly, called as evolutionary learning. So we have got supervised learning, unsupervised learning, reinforcement learning, and evolutionary learning. Supervised learning can be used for prediction and classification related problems. Unsupervised learning, it is going to be helpful for identifying groups or clusters. Reinforcement learning, it is penalty based learning. It can be appreciation or punishment. It is feedback. Evolutionary learning, we will have to talk about it a little later. It is growing and more research is happening in this side. Now, let's get deeper into supervised learning algorithms. What is it? This is very simple, where we use the labeled data which are gathered from the past. I have lot of data, all of them are labeled and they are gathered from the past. They will be used to train the model, and then the model will be able to predict or classify the test data which is not labeled. I have got bunch of data, I have labeled it, I train my model with that, I use that model to predict or classify the test data which is not labeled. That's all. Supervised machine learning algorithms definitely uses labeled data, and we are going to give a very simple example. You are provided with a very strong set of data which contains images of cat and dog. We have 1000 images for an instance of cat and dog each, and we are now going to create a supervised learning model where we will train the model using 700 labeled cat data and 700 labeled dog data. We have kept 300 cat and dog images away from us right now. The system is exposed only to, the model is only exposed to 700 labeled cat data, labeled dog data. 300 are not exposed to the system. Once the model is built, we will make the model predict the test data, and we can check the accuracy. We have got 1000 images, 700 of them are labeled for cat and dog. We are now training the model. Now we make the model predict the rest of the 300 cats and dogs which are not labeled. That's all. Very simple, and then we can go ahead with predicting the accuracy. That's it. A simple example is this way. A teacher is showing apple in the day 1 and calling the students to identify what is it. Students first day will not know what is it. So teacher every day will start telling that this is an apple. Day 1 she says, day 2 she says, day 7, day 8, day 9, day 10 she conveys that. Day 11 when the apple is shown, the student will jump and say that this is apple. That's all. This is supervised. The apple is labeled. She is training the students with the label data, and one fine day she is bringing a new apple and she shows what is it. Student will be able to identify it because this is supervised learning. We have the data set here. You can see that sample, cat and dog label training data set. We have got test data set also with us, but they are not properly labeled. As you can see here, it can be cat or dog underscore 1, cat or dog underscore 2. We are training the model with the label data, and we are feeding the test data into the model to predict what it is, and the model will predict. That's all. This is supervised learning. One of the major points here to be noted is that if the model is trained using wrong label data, the output will certainly be wrong. It is like karma. It is very powerful. Whatever you train, that will be the result. And the training data that you feed should be properly chosen, and that decides how your output will be. Also, if the model is not trained with certain scenarios, it will not be able to recognize that particular items. For example, my system is trained to detect only apples, to identify only apples. If I show jackfruit, the system will not identify that. And I have not trained the system with the jackfruit images, and hence the failure is inevitable. So choose the data set properly, train it appropriately, and results will be really very nice. Unsupervised learning is the next approach. This is slightly different from the supervised learning model. The supervised learning model is completely dependent on the labels which are associated with the data. There is an explicit training, there is explicit testing associated with supervised. But here we do not have that. We are going to consider a scenario where a student is given with set of dogs and cats images. There is no label associated at all. Every day, this data set is given to the student, and after about a week, the student is asked to categorize the similar images in the data set. The student is not given a labeled image. The student is given bunch of data which has no labels, but we have given him the data set for a week and he is with the data set for a week or so. And now student has been going through seeing different type of images for about a week. Now student would be definitely getting smarter and he can identify the features of both cat and dog images. At the end of the week, definitely the student based on features would be able to classify dogs and cats. But there are some real good cats which will look like dogs as well in the images. We cannot help it. There could be some errors. But this is the way unsupervised learning works. Reinforcement learning is very interesting. I've got a picture for you here. Your son is walking along with you in the roads and you are asking by showing an apple, what is this? Your son says that it is orange. Immediately you will correct him. No, my boy, it is apple. And then the son will say that, apologies mom, I will correct it. Next time you are showing apple and asking him what is it? This is an apple will be the answer. This is called reinforcement learning. That's all. Simple. We learn if there is a mistake, we learn it definitely through the feedback and we correct ourselves. You must have seen the computer chess game where maybe the first game the computer will lose, second game also it could lose, third game it will learn from its mistakes and it can definitely win. The player may not be able to win the third game because it would have learned from the mistakes. This is called the feedback based learning. The first time the model may fail, second time it learns from you and it interacts and it learns from you, it will evolve and therefore there will not be failures. So this is called reinforcement learning algorithms. The evolutionary algorithm is still evolving. These types of algorithms will be imitating the natural evolution to solve any particular problem. We'll talk about it more in the near future and for now we can put it on hold. That's it. We'll go to the next session shortly and I hope it was an interesting session. If you have any questions, go ahead and type it in the chat section. I'll be happy to answer. Thank you.